All right, this video is just a bunch of practice, okay? Showing you how to use these properties. Theorem 3.8, the derivative of sine and cosine. Let's take some derivatives. Does that I have two dots? Find the derivative of the following. The I should have two dots though, you know? Two dots for two i's. That doesn't even make sense. Let's look at the derivative of f of x equals 5x cubed times sine of x. So, first off, don't write this down. Oh, my word, cat, what are you doing? Don't write this down, but I'm going to make a mistake. This is the wrong answer. Now I want you to think about this and say, why is this wrong? Think about this for a minute. What did I do wrong? Derivative of x cubed is 3x squared. You can multiply that by 5. Derivative of sine is cosine. What's the problem? The problem is we have to use the product rule. Okay? We have two functions of x multiplied by each other. So don't do this. All right, we need the product rule. This can be our f. This can be our g. And the product rule, well, maybe not f and g. We already have an f. Call it something else. Hey, can you erase, please? Thank you. Call it h and g, because we already have an f. Let's not be confusing. So product rule says derivative of the first times the second plus the first times the derivative of the second. So sometimes it can be easier to go off to the side and just write these things down. H prime going to be 15x squared. G is sine, and so g prime is cosine of x. We talked about that in the last video. So now we just replace everything. H prime, that's 15x squared, times g, that's sine of x, plus h, that's 5x cubed, times g prime, which is cosine of x. All that's left is tidying things up a little bit. Here, I don't have a strong preference which format you put it in. So like, for example, this is okay. But you could also take out the greatest common factor, which would be 5x squared. And that'd leave you with 3 sine of x plus x cosine of x. These are both okay. I think the book would probably do the second one. I myself would probably do the first one, but it kind of depends on the context. So I'll take either answer. I don't have it kind of depends on what you're doing with things afterwards. If you're taking the derivative or something, the top form is easier. If you're trying to simplify a fraction, the bottom form is better. But they're both good. That's it. Let's do another one. Y equals the cosine of x over 4x squared. Now you have two choices here, depending on what you like. You could use the product rule or the quotient rule. You might say, that was a weird sneeze. You might not say that. You might say, Jason, I can't use a product rule here. There's no product. There's only a quotient. Well, if you said that, you'd be wrong. But it's okay to be wrong. So here, let's, kind of show you both ways. Let's do the quotient rule first. Quotient rule is probably what a lot of people would do. So f is cosine of x. Prime is negative sine of x. G is 4x squared. And g prime is going to be 8x. So we know from the last section that the quotient rule says low d high. Wait, high d low. Wait, low d high minus high d low. Whoa, I forgot it for a second. Low d high minus high d low. Square the bottom, and away you go. F prime, that's negative sine of x. Times g, that's 4x squared. Jason, you didn't leave yourself enough room. We're going to do some weird curvy math. That's a subtraction sign. A very droopy subtraction sign. Minus f, which is cosine of x, times g prime, is 8x. And then we got a fraction bar that looks like this. Divided by g squared. 4x squared squared. And again, you could simplify this a little bit. You could factor it. Since it's a fraction, usually with fractions, we like things factored. We can take out a 4x. That's going to leave us with a 2 times cosine of x minus an x times sine of x. And you might say, Jason, why do you switch the order? And that's just because we usually like having positive quantities first. So we're factoring and switching the order. So when we factor it out of 4x, we're just left with 2 times cosine of x. Factor out of 4x, we're left with an x times a negative sine x. And that's why I did it this way. And the bottom, when you square it, make sure that you're squaring both parts. 4 squared is 16. And x squared is x to the 4th. And this is why we factor for fractions. This is why we factor for rational expressions. Because you can only cancel if you do factor. That cancels like that. That cancels like that. So what we're left with is just 2 cosine x minus x sine of x all over 4x cubed. And you remember, you cannot cancel these because it's not factored. You can only cancel common factors. It's the subtraction sign that really screws us up. That should be our answer. That's y prime. But you could also have done it with the product rule. You could have rewritten this as 1/4 x to the negative 2nd times the cosine of x. And this is a little easier, I think, because the product rule is just easier. Quotient rule is usually harder. And if you did it this way, you'd derivative of the first would be negative 1/2 x to the negative 3rd times the second plus the first, which is 1/4 x to the negative 2 times the derivative of the second, which is negative sine of x. All right. And hopefully this is going to get us the same answer. So what does this give us? We can factor out a negative 1/2. Well, there's a couple of ways of doing it. If we want to jump to show you why it's the same answer, then we would factor out a negative 1/4. And then what are we left with? We're left with 2 cosine of x over x cubed plus sine of x over x squared, which is still not quite the same. Wait, I'm off by a negative. Oh no, what did I do? Oh no, what did I do, guys? There's a mistake somewhere. Where's the mistake? Which side is it on? Because I'm off by a sign. Good thing we checked our answers. Derivative of cosine. All right, f prime is negative sine of x times g, which is 4x squared, minus, oh, they're both negatives. They're both negatives right here. Going from this step to this step, I made an error. Hopefully you caught that. Hopefully you were like, Jason, what about your minus sign? See, it's this stupid minus sign. I shouldn't have tried to do this. I tried to do a droopy minus sign and I forgot about it. Oh man. That's a minus sign. They're both negative. So let's factor out a negative. Now they're both positive. We can put that negative in front, kind of like so. Jason, you trying to be a little cheeky. You're getting yourself in trouble. All right. And now, you know, what is that? You get a common denominator. Multiply x over x. And yeah, that's going to give us negative 4x cubed 2 cosine of x plus x sine of x. See, nobody likes a quotient rule. Product rule is easier. All right. And in a previous video, I showed and compared 2 answers and said, hey, they're the same, just like we expected, but they weren't the same because I made a mistake. I'm not doing it this time. This time they are indeed the same. All right. Great. Okay, so I went through this one pretty quickly just to kind of show the other way of doing it, but it's best to show your steps like this. Whew. All right. Let's go back to our favorite little particle. Our particle moving on a coordinate axis, shall we? So we got some particle moves along an axis with position function s of t equals 2 sine, that's not an s, Jason, 2 sine of t minus t, and t lies in the interval 0 to 2 pi. Oh, inclusive apparently. And the question is, what the heck is this in your notes, Jason? What is poved? What does poved mean? P-O-V-T is what it looks like. Oh, it's supposed to be part. I abbreviated particle as part. When is the particle at rest? I wrote it like this. Who writes particle like that? Come on, Jason. When is the particle at rest? So at rest, right? That means when the velocity equals 0. That's what it means. So all we have to do is find the velocity, set it equal to 0. So the velocity is just the derivative with respect to time of the position. So we just take the derivative with respect to time of this function. This is a constant times a function. So constant multiple rule says it's just going to be 2 times the derivative of sine. What's the derivative of sine? Cosine. Minus the derivative of t with respect to t is just 1. When is that equal to 0? Well, let's just add 1 to both sides, divide by 2. Remember how to solve your trigonometric equations. 2 cost equals 1. So cost, please don't say cost. Don't mimic me. Teachers are supposed to provide a good example, but sometimes. When is the cosine of t equal to 1/2? Well, you're going to have to remember some things about trig. Remember your reference triangles. All right. One of the big ones was a 30, 60, 90 triangle. Cannot draw this small. This is 30, 60, there we go. 30, 60, 90 triangle, and it had these ratios. 1, 2, √3. Well, cosine, SOHCAHTOA, cosine is adjacent over hypotenuse. So when is the adjacent over the hypotenuse equal to 1/2? At 60 degrees. But that's not the only answer. So 60 degrees, and again, we're usually going to be using radians in this class. It's pi over 3 radians. That's not the only one. You have to remember, where else is cosine positive? I taught pre-calc last quarter. What did I use? I've used all seniors take calculus. I've used all squids train camels. Is that what I used last quarter? I don't remember. All squids train camels. However you want to remember it. Always save the cats. However you want to remember it. Cosine is also positive in the 4th quadrant. But I'm going to make a mistake here. What's the problem? Negative pi over 3 is the same reference angle in the 4th quadrant. But it's not in the right interval. We're only caring about time between 0 and 2 pi. So don't do that. We need to say, okay, what's the same interval? What's the same angle, sorry? What's that same angle, reference angle of pi over 3 in the 4th quadrant? That's going to be 2 pi minus pi over 3. Right, we're going around 2 pi or 360 degrees, but then we went pi over 3 too far. So that's going to be 5 pi over 3. And to see where that comes from, you can just say, okay, 2 pi minus pi over 3. We need a common denominator. It's going to be 6 pi over 3 minus 1 pi over 3. Oh, I should have gone back to blue. I did white though. That's going to be 5 pi over 3. All right, and that's when the particle's at rest. And for a lot of these, you can kind of graph them as well to sort of, like, graphing these is kind of hard to check your answers, but there's a couple of ways of kind of going about it. Like, if you just look at this first one, our function is 5x cubed times the sine of x. I don't know if this is going to work. I think it's going to work. 5x cubed times the sine of x. And then, ooh, that's kind of wacky. And then if we look at its derivative, the derivative is 15 or 5x squared times 3 sine x plus x cosine x. So now, all right, so you might be saying, Jason, how is this supposed to be useful, Jason? Well, don't worry. Let's just make our axes look a little nicer. Let's not look at so much. And then let's zoom out a little bit. Negative 10 to 10. Yeah. This doesn't have any asymptotes. How is it getting so big? 30? 30? Bigger? 50 to 50? Okay. So it looks a little bit better. A little bit better. Now, before you protest too much, let's connect the concepts from earlier. The blue is a graph and the orange should be the derivative. So whenever you're trying to think about function versus derivative, think about the easy points. When a function is at a maximum or a minimum, a local max, local extrema, we haven't officially talked about this, but this is where the function has a horizontal tangent line. Here, here, and here. That's where the blue graph has a horizontal tangent line. Horizontal tangent line means the derivative needs to be 0. Is the derivative 0 at these points? Well, derivative is the orange graph. When x is negative 2.4, orange graph is 0. Here, the orange graph is 0, and here, same x coordinate, orange graph is 0. Good. So that's like one way for us to tip us off that, okay, this, it doesn't prove that we're right, but it helps us. It helps us know. And then you can also like say, look at between these 2 points. Between these 2 points, blue graph decreasing all the way. It has decreasing, that means it has a negative slope. The derivative should be negative between these 2 points. And indeed, look at the orange graph between those 2 points. The orange graph is indeed negative. Connect the concepts whenever you can. And you could just spend more time looking at these and talking about these. And this, to really verify why this is helpful for checking your answer, let's go to the one I made a mistake on. I had a minus sign on, for cosine of x over 4x squared. I'm gonna plot my mistake. All right, my error. So my error was writing it as 2 cosine of x minus 2 cosine of x minus x sine of x is what I wrote over 4x cubed. So this is what I wrote. And I'm curious, I don't know the answer to this, but I'm curious, would this have tipped us off? Would the graph have tipped us off that I made a mistake? Well, the blue graph doesn't really have any horizontal tangent lines, so it's kind of hard to see. But you can tell, look, the blue graph is increasing. The blue graph is increasing on this interval. So why is the orange graph negative? If the blue graph is going up, that means a positive slope. That means a slope, the derivative has to be positive. But the orange is negative here. So that would tell us right off the bat, hey, this can't be the derivative. And in fact, I believe this was the derivative. You can see, yeah, blue graph has positive slope. So the slope is so the function value of the orange graph is positive, right? Reading this tells us that the blue graph, when x is equal to negative 0.6, the blue graph has a slope of positive 1.6. The derivative function, the orange function, will always tell us the slope of the blue function, the original function. All right? And that's basically what we got here. Let me know if you have any questions. Yeah, that's this video.